Hello everyone. We are now going to conduct our fifth lab. It's entitled Current Circuits Basics Lab. So as we did last time, I'm going to read the instructions and the questions, and as I go along, I will also be solving some of the problems, or at least I'll be showing you how to solve them. Alright, so let's start with the first one. So it says, create a simple series circuit using one battery, one bulb, and one switch. Alright, so that's pretty easy. So we need a battery, so the battery is here. We need one light bulb. One light bulb is here, so they are in the left margin of the screen, and one switch also on the left. Okay, connected to the battery. But to connect all the pieces together, of course, now I need wires. Connect the bulb and the switch with a wire, and then the light bulb and the battery with another wire. Okay, and now the circuit is open, so there's no current flowing. But when I click on the switch, I close it, and now current flows. But of course, you can see that in this case, the current is flowing in a clockwise direction, and that's because the positive terminal of the battery is here on the right. The negative terminal is on the left. Okay, that's not the conventional direction of the current. Okay, so to get the conventional direction, which is a direction opposite that of the flow of the electrons, so in this case it will be counterclockwise, you can just click on conventional, and the red arrows now show you what the conventional direction is. If you are confused about the position of the positive and negative terminals, you may want to use the symbols that we are more familiar with in for circuits that you will find in textbooks. And to switch to those, you go to the right margin at the bottom and you click this symbol, and it gives you now the symbol for the battery. Okay, and now you can see clearly that the right part of the battery is the positive terminal, and the left end is the negative terminal. So it makes perfect sense that the current is flowing in a counterclockwise direction now. And you can see that all the other pieces of the circuit have the corresponding symbols, okay, that you will find in textbooks. Okay, for the battery you have this, for a wire you have this, for a resistor you have this, for a switch you have this symbol in the left margin. Okay, if you don't like this, then you can go back to the pictures that you had before. Okay, all right, so that gives us our simple circuit. Now, the second problem. What is the voltage of the battery in your series circuit above? Which instrument can you use to measure voltage of your battery? Well, without any instrument, you can find the voltage of the battery by clicking on it, and at the bottom of the screen you can read the voltage, which is 9 volts here. okay, and you can change that voltage to 26 volts, okay. See that the light shines more brightly, and even a higher value, and the current is faster, or to a lower value, okay, and the light doesn't shine as brightly as before. But let me take it back to 9 volts, because that's how it was before. Alright, so now there's another way of finding the voltage, and that's what the second part of the question asks you. Which instrument can you use to measure the voltage of your battery? Of course, that's the voltmeter, which is I'm going to bring here. And what I have to do is take this stub lightly, then place it on the left, okay, at the negative terminal. Take the red one and place it on the right, on the positive terminal, and the voltmeter will automatically tell me what the voltage of the battery is, which is 9 volts. Okay, so that's how we solve the second problem. Alright, so let me take that voltmeter back where it was, and then try to show you how you can do the third problem. What is the current in your series circuit above? Which instrument can you use to measure current flowing in a circuit? Okay, well, you can use calculations to find that current, okay, since you know what the voltage of your battery is and what the resistance of the battery. If you click the resistance of the light bulb, if you click on the light bulb at the bottom of the screen, you'll find the resistance, which is 10 ohms in this case. So knowing this resistance and knowing the voltage in the battery, you can easily calculate the current in your circuit, because this is a very simple circuit. Okay, for more complicated circuits, of course, it's much more difficult. Right? So that's one way, by performing calculations. Another way, which also at the same time answers the third part of the question, or the second part of the question, question number 3, is by using an ammeter. Okay, the ammeter will tell you what the current flowing in your circuit is, but an ammeter must always be placed in the circuit. You cut it here, cut the circuit there, connect the ammeter with the light bulb, and then with the wire, and I can read that the current is 0.9 amperes. Okay. So that's the magnitude of the current flowing in this simple circuit. Now the fourth problem. How can you determine the resistance of the light bulb in your circuit? Okay. So the resistance of the light bulb. So of course here, let's say that you don't know what the resistance is. Okay. If you don't know what the resistance is, but you know what the current is, and you know what the voltage is there a way of finding the resistance of the battery? Okay. Of course there is a way, and if you go through your textbook, you will find it. Okay. I'm not going to answer this question, but there is a way to help you. It's just an equation. It's a formula. It's an equation. Okay, and with that, you'll be able to calculate the resistance. Okay. Now the fifth problem. What is the resistance of the bulb? Okay, so using the equation you found in problem 4, then you can find the resistance of the light bulb. Okay. So the second part of the problem is what tools can you use to find this information. Okay. So I'll let you find out. The sixth problem says set up a circuit where there are 3 bulbs and 3 switches in use. Create this circuit such that when one switch is open, all the bulbs go out. So how are we going to do this? We can get rid of the present circuit here, or we can modify it. I opt to modify the circuit. So the way I want to do this is by placing 2 light bulbs in series and a third light bulb. So let me get rid of this wire. And a third light bulb in parallel with the first 2. Okay. So that's how I want to do that. But you don't have to do it this way. Okay, you can do it any way you want. Okay. So, but we need 3 switches. So I need another switch here. So so I have 2 switches already. The last one, and I'll connect the switch, and here, and this part of the circuit, this part of the circuit with a wire that connects the 2 light bulbs with another wire. Nice. Now the last connections. And that's it. I have my circuit with 3 light bulbs and 3 switches. 1, 2, 3. Okay. No current is flowing in this circuit, of course, because it's an open circuit, so let's close it. Switch. Now current is flowing. Okay. If I open this switch, the bottom switch, no current is flowing anywhere, in any part of the circuit. Okay. If I open it, if I close it, I restore the current in the circuit. Now, the 7th problem, would this type of circuit which you made in part 6 above be suitable